Hello. Hi guys, good morning. Welcome back to a new video. In this video problem, minimum cost to equalize the array. 3 points. Firstly, we will see Lee provided an awesome solution. We will see the entire proof of it. Although he provided solution, but there was not even a single intuition on neither the proof, but we'll see everything. Secondly, if again this video takes a lot of, again, this is not like the existing problems, like as you can see, this takes a lot of efforts to even make these all nodes. As you can see, like this is a very big, again, this is very big, it's going to be very big. It takes a lot of efforts, and after the work it's very hard to get time to actually make these kind of long videos. So if this video doesn't get 150 likes, these kind of long ones I'll skip. Again, like the post contest ones, I'll skip it because no one will explain this deep, and also no one will actually bring in with these explanations. And yeah, people don't like it, don't share, there's no subs, like there is no motivation at all. So it's very hard to like spend 4 hours to make these and spend like another hour to record and then all this stuff. Okay, writing gets done. Let's start. It simply says that we are given an array of nums and 2 integers, cost1 and cost2. Now we have, what's the operation like? We have to choose an index. Again, we have 2 operations. First operation is choose an index I and increase nums of I by 1. Okay, which means, okay, I have an array nums, I can choose any index, I can increase that index by 1, the value of that index by 1. Next operation is what I can do. Again, this first operation will give me a cost of 1. This one operation has a cost associated, and that cost is cost of 1. Next operation is choosing 2 indexes I and j, and then increasing both of them simultaneously with this operation 2. Again, I'll name this as operation 1 and this is operation 2. With this operation 2, I'll increase I and j. Again, both of them are different indexes. I and j, both I'll increase by 1. This will give me a cost of 2. I have to find the minimum cost required to make all the elements of the array equal. Now, before jumping on to any part, we will derive some things from the examples itself. Every example will give you something to start off with. So let's see first example. We have nums as 4 and next nums of 1 is 1. We will, again, we know that all these are numbers. We have to make them, all these numbers, we have to make them at equal height. So let's plot them as a bars. So, okay, we have first bar at a height of 4, next bar at a height of 1. For sure, I have 2 options. I'll ask you both the options. I'll ask you firstly, should you apply option 1? Option 1 will take one element and will increase it. So what you can do, you can increase this 1 to 2, 2 to 3, 3 to 4 in 3 steps. In 3 steps, as in after applying 3 operation ones, you can ultimately match the height of 4, and now you have become equal to 4. Okay, what if I ask you, would you like to apply operation 2? You will say, bro, if I apply operation 2, I have only 2 numbers, 4 and 1. If I apply operation 2, which means both of them will increase. Both of them will increase. I need to match both of them. If I increase both of them, then what's the point? There's no point. That's the reason. This first example gave me a derivation, or gave me a hint that, okay, I learned that if I have only 2 numbers, it's always beneficial to just increase the one which is minimum and try to bring it at par with who is actually maximum. There is no point increasing both of them because you have to reach to 1, right? So this gave me this learning that, okay, if I have only 2 numbers, I should make my small number reach to my higher number. That is the learning from the first example. Okay. And in the first example, we saw that we only used operation 1. Operation 2 was not even used. Is it required we use operation 2? Maybe not. Let's see. So this is example 2. We have the heights of 2, 3, 3, 5. Again, let's plot these heights. 2, 3, 3, 3, 5. Now I have to start placing. Again, I am greedy. I will choose, okay, Aryan bro, I will use operation 1 only. If you use operation 1, you know that this is the maximum height, which is 5. I am not mentioning that everyone has to reach to this maximum height. So right now, let's imagine that everyone right now have an aim of reaching to this maximum height. And they are thinking that by reaching to this maximum height, they all will become equal. Although it is possible that all of them will become equal by reaching this maximum height, but for minimum cost, I might actually overshoot this maximum height. Why? We will see it later on. But remember this, it can happen. I will give with example and proof why this will happen, but remember, it can happen. Although you will not think of it, but still it's an edge case which can come. But so far, right now we just thought of, okay, we will just reach to the maximum height whatsoever possible. If that's the case, then we know the gaps left. Again, these are the bars. 2 is a bar, 3 is a bar, 3 is a bar, 3 is a bar, and 5 is a bar. So the gaps left are actually 3, 2, 2, and 2. Again, how you derive these gaps? These are 5. Again, your aim was to reach 5. You are at 2. So what is the gap? 5 minus 2. This is 5 minus 3. This is 5 minus 3. This is 5 minus 3. This is 5 minus 5. Here the gap is 0. So if you would take operation 1, which means you will go one step, which means total number of gaps I have gap is 9. I have total 9 gaps. For each gap, you are using one step as in operation 1. So for 9 gaps, a cost of 1 will be a 2. So cost is 18. But is the answer 18? No, answer is not 18. Answer is 6. Why the answer is 6? Because they were saying, get me the minimum cost possible. So how will you get the minimum cost possible? Simply, I will take 2 bars and then place parallelly. I know that if I take operation 2, I can fill one gap in 2 bars simultaneously. So, okay, let's imagine that I am using gap operation 2. So I am filling this gap simultaneously. Okay, operation 2, 1 is done. Next, let's say I fill this gap. Operation 2, 2 is done. Let's say I fill his gap. Operation 2, 3 is done. Let's say I fill this gap. Operation 2, 4 times is done. And then I can for sure see I have to bring my bar to the 5 limit. Everyone is done. Just 1 is remaining. For sure, I will have to apply. I will have to apply my operation 1. So for this 1 remaining, I will apply operation 1. Now, make sure I will still prove it is not required to apply this operation 1 for sure, because I can increase my maximum limit. But considering my maximum limit is set to 5, that is the reason 1 block will have to remain for sure, right? Thus, I will have to use up to cost of 1. So 1 cost of 1, and you know that 8 gaps resulted in 4 operation 2. 8 gaps resulted in 4 operation 2. So it is 8 by 2, which is 4. And the cost of 2 is 1. That's the reason my minimum cost came out to 6. So from this example 2, we had a learning that it is not necessary that operation 1 will give you optimal answer. Using operation 2 can also give you an optimal answer. So with this, we learned that operation 2 can give us good answer, and we will try to use as much operation 2 as possible. But in what case, we will see. But we'll try to use as much as possible operation 2. If not, then operation 1. Now, but still, there are 2 facts. There are 2 still things which is missing. One thing is, which should have come to your mind so far, is that, Aryan, how did you place these 2? Like, how did you apply operation 2? Did you do it randomly on any blocks available, or did you apply some strategy? We will see. But with this learning, we applied that. Okay, we just applied it randomly, and then we just got the answer. But we applied option 2 first, and then for the remaining one, we applied our option 1. But strategy to apply operation 2 will also matter. So let's see that. But before going on to that, let's see last example. Every example is giving us some learnings, right? So this example says that you have this 353. Okay, 353 gaps are this. By, as Aryan told previously, that if I know I can apply operation 2, I will apply operation 2. Okay, if I apply operation 2, 1 gap here. So I know I have 2 gaps. Like, I am filling 2 gaps by operation 2, and then for every operation 2, I am having a cost of 3. Answer will be 6. Answer is 4. Why is the answer 4? Because in this case, I applied operation 1. I had 4 gaps. I applied operation 1 and got the answer. Okay, so now you know that at what point you should for sure apply operation 2. See, if I gave you 2 blocks and I ask you, should you apply operation 1 here or operation 2 here? If you apply operation 1 here, then 2 into cost of 1 will be applied here. 2 into cost of 1 will be applied here. If you apply operation 2 here, then simply a cost of 2 applied here. When it is super beneficial for us to apply operation 1. When this 2 into cost of 1, it is actually less than my cost of 2. Or maybe you can say less than equal to. Then it is always good to apply my operation 1. In other cases, I will always try to apply operation 2 first, and then for the remaining ones, I will apply operation 1. So this learning 3, or example 3 gave me a learning that in the case when cost of 1 into 2 is less than equal to my cost of 2, I should for sure apply my operation 1, which is cost of 1. And in other case where my n is actually less than equal to 2, which is example 1 we saw, then also I'll apply operation number 1. Now we also have to make sure a few specific things, as we were seeing here itself, that first thing again, although I will show you, but the first thing which you will see in code is I will have a mx, I will have a mn, maximum element in the array, maximum, as you can see, maximum element in the array is 5. Again, you don't need to worry about it. I will show you in the end also that, again, as we go on, I will show you everything. But let's see that I have already had these variables. So you will know I already had these variables. Mn is the minimum element, which is 2 for us. N is the size of the array, which is actually, you can see 1, 2, 3, 4, 5. Then mod, as you have to take the mod in the answer. So it's a mod. Now, SU, again, I will take the sum. It is the sum of all these elements. Aryan, why it is required? It is required because, as you remembered, you have to find the total gaps left. What is that? It is nothing but 2, 3, 3, 3, 5 in the subtraction and size of the array, which is n, multiply the maximum element, which is mx. So mx, my mx into n minus sum is actually the total number of gaps left. So this is the total number of gaps left, which is maximum mx into n minus sum. Okay, now you know these variables. Now let's come on and see for the total number of gaps left. I know for every gap I'm applying operation 1. So the cost will be cost of 1 for every gap. For total number of gaps into cost of 1 will be total gap. And doing a mod. Okay, case 1 is done. This is the case 1 which is done. Now comes the interesting fact. When will I actually apply my operation 2? Now, as you saw in the example 2 also, that one possible case is, which is that I will, again, no matter what, as this is done, I know operation 1 optimal, I applied it for sure, it's good. In any of the other cases, I will for sure try to apply my operation 2 first, try to exhaust it as much as possible. Then if in the worst case my 1 is still remaining, then for that specific 1 left, again only one element will remain, only one gap will remain. For that only one specific gap, I will apply my operation 1. That's it. So we realized that we have to exploit our operation 2. If I exploit it, which means, as I saw in example 2, I will try to bring all my bars equal to the maximum height. And then again, my best case, I will try my best. I'll try my best. When I say my best, I actually mean my best, even if there's still a chance that one gap can still remain. But still, I'll try my best and will try to bring all of them to the maximum value. But you will see, I also mentioned it is not necessary that your best case possible can only be at the maximum value. It can go beyond maximum value as well. What I mean by beyond maximum? I mean by beyond maximum is that here in this case, your maximum was a 5. You were bringing everyone to 5. Now I'm saying your actually optimal answer can go beyond 5, which means it can go to max of 6 also, or 7 also. That also can be possible. We will see with explanation examples how is that possible. But coming on back to our cases, we will go on to the first case when we are using operation 2 optimally, and we try to bring everyone to the max height, which is itself in the input. So for our example, let's take this example. This was the input array. We just plotted the bars 1, 3, 3, 7, 7. Now we just got the gaps. Gap is 6, gap is 4, gap is 4. We got these gaps. Now we know ultimately we have to just move these gaps, like remove these gaps. So ultimately I have to make sure I have to reduce all these gaps to 0. Reduce as in like I have to just get rid of all these gaps, and I have to And how I can do it? I can apply operation 1 or operation 2. That's what I wanted. But make sure you have to reduce all these gaps to 0. This is the gaps, and ultimately you want to get rid of it, and get rid of it as in get it to 0. Now, first, one very basic diagram which I need you to remember for future is that if you have some gaps, I can represent those gaps in a form of an array. Where's this gone? Okay, no worries. Let's take it later on. But if I have these gaps, I can simply start saying, okay, Aryan, I will use operation 2, and I will simply apply operation 2, and I will take use of it. If you try to apply operation 2, one very basic greedy approach, again, you know your aim, maqsad, your main aim is that you have to reach to 0. If that is the aim, you need to make sure, okay, all of these have to reach to 0. If you apply a greedy approach, Aryan, what I will do, okay, I know that I have 6 gaps here, 4 gaps here. I will take 4 gaps from both the sides. Operation 2 applied 4 times on both the sides. So, okay, 4 pairs removed. Then I will be remaining with the 0 pairs here, 2 pairs here. Then again, greedily, I will take 2 pairs from both the sides. 2 pairs remain, like 2 elements, like 2 gaps remaining here, 0 gaps here. Ultimately, I know that, okay, at one element, at one place, at this specific one place, I have 2 gaps remaining. For sure, it is at the same index, I, right? Here it was I and j, so I can apply my operation 2, but it is at the same index I, right? 2 gaps at the same index I. Oh, if that is the case, I cannot remove it with operation 2. I have to use 2 operation 1s here to remove these 2 gaps at the same index I. So you realize that I use operation 2 6 times and then operation 1 2 times. But I already mentioned to you that you have to try your best to use operation 2 as much as possible. If that would have been the case and you used your operation, again, you used greedily, you just took 2 of the operations ones, like gap ones, maximum ones, you just removed all of them entirely and then you just gave the answer. If I showed you that if you would have, although again a bit greedy, but step by step. So I had these many gaps. I will take out 2 maximum gaps and only make a pair out of those 2 gaps, right? So I take these 2 maximum out, I reduce one gap out of them. Okay, he became a 5, he became a 3. Now again, take 2 maximum gaps out. Now 2 maximum gaps out are 4 and 5. Again, reduce one of them. Reduce, I got these, right? Okay, now again, take 2 maximum gaps out. These are 2 maximum gaps out. I reduce them, right? Okay, these I got. Now again, take 2 maximum gaps out. Okay, 2 maximum gaps out. Again, I reduce both of them. I got this. Again, take 2 maximum gaps out. 2 maximum gaps out. I got 1. Again, take 2 maximum gaps out. 2 maximum gaps out. Okay, I got 1 0. Again, to get 2 maximum gaps out. Okay, I got all zeros. So you realized you used 1 2 3 4 5 6 7. You used 7 operation 2s and got your answer. Here you were using 6 operation 2s and 2 operation 1s, but here you used 7 operation 2s and got your answer. What if I tell you the cost of operation 2 was 1 and cost of operation 1 was 1/6 maximum? Then with this example, you would have incurred a cost of 6 plus 1/6 into 2. But with this strategy of using operation 2, you would have incurred a cost of just 7. That's the reason utilizing operation 2 at its best is very important. So you realize, okay, Aryan, then you are saying that I have to reduce step by step. Yeah. And I also realized, again, to find out the complexity, again, although you might say this, and the first example which might click your mind is priority queue. I'll put all these gaps in the priority queue and then I will remove the maximum 2, reduce them by 1, push them back, again take out, reduce them by 1, push them back. This is what you might think, but have a think of the complexity of that. The complexity of that will be, as you can see, at each step, you are reducing the total value. Again, let's imagine this is a total gap value. You are reducing this total gap value by 2 at every step. You are doing it. So I might say that number of steps required will be, if I have this total gap value, I know at every step I'm reducing that by 2, by 2, by 2, by 2, and so on and so forth. So ultimately, I can say that this is a total gap value, which is a sum. So total gap value by 2 will be the number of operations or number of steps which my priority queue will be performing. Which in my case, my total gap value can be, in worst case, okay, I can have n elements, and for every element, the maximum gap value which I can have is directly proportional to maximum of nums of I, which is 1e6. It will be 1e11. And also you are saying if you will use a priority queue or a multiset, a log factor will also come in picture. So the complexity, if you use a priority queue or a multiset, will be a 1e11 into log of that, which is TLE. How to actually utilize that? Or basically, you know that you have to use something else. What is that something else? Let's see now. So you realize one thing, that you have these gaps, and you also remembered your main aim, which is maqsad. Now, if you remembered, I was mentioning a diagram in the when I was telling these gaps you have to represent. Make sure I will tell you a diagram, which although right now it will not be used, but make sure I will link it later on. So remember, these gaps, I can also represent them as an array, saying that this is the array, this is the frequency that a specific gap is occurring how many times. A gap 4 is occurring twice, a gap 6 is occurring once. This is what I will show later on to prove something else, but make sure I have showed you here itself. Now, coming on back, we realized that one thing, that at any point when I was trying of this priority queue stuff, I realized that the maximum gap was the one who was contributing, that who should be taken for operation 2. So I realized at any point of time, my maximum gap always gets the priority. First thing, how will you find the maximum gap value? So if I again, in the very initial phase, the maximum gap value is the maximum value of the array nums, which is 7, minus the minimum value of the array nums, which is 1. This will give me a value of 6, which is the maximum gap value. So this is maximum is the maximum value of the array, minimum is the minimum value of the array. This is a 6, which is the maximum gap value. Now, if you had remembered in the very beginning, I also showed you that we have already computed the total gap, which was, if you remembered, n into maximum value minus sum. So considering that you know these two variables exist, now let's see. Now, we remembered that we have to use cost 1 minimal number of times. That I will only use cost 1 when it's actually super necessary. So let's see when this cost 1 will have to be. I'm not saying I will use, will have to be used. So what if again, remember, you are still at a point when you have to bring all of them to the same height, and that height is mx. So now I'm saying at what point you will have to use cost 1, which is operation 1. I'm saying, what if I cannot form pair with the maximum gap? So you remembered that this is the maximum gap. Maximum gap is 7. Now I'm saying, okay, all the other gaps will actually try to make a pair with the maximum gap. But Aryan, it is not necessary, right? I can still have many other gaps which can form pair with each other. So okay, yeah, that is true. We will look at later on. But let's see that what if maximum gap whatsoever you have, and all the other gaps combined cannot even form a pair with the maximum gap. What I mean by that is that you can see I have 4 and 6 gaps. I have 7 gaps here. I have 7 gaps here. Okay, whatsoever it is. I have 7 gaps here. I have 4 gaps. I have 2 gaps. So even if I make 4 gaps with this pair, 4 pair done, 2 pair done, 2 pair done, still a 1 gap will remain. So this will show us that the maximum gap I have, even if I take all the other gaps, still I am not able to make a pair with the maximum gap. There is no possibility I will anyway in future will be able to fill my maximum gap. So if maximum gap is more than the other gaps, then I know that, okay, no matter what, I will not be able to fill my maximum gap to that point, mx. What will be the number of, what will be the remaining number? That remaining number will be this remaining number will be maximum gap minus other gaps, will be a remaining number where I will have to apply operation 1. So what is maximum gap? Maximum gap. What's the other gaps? Other gap is total gaps minus max gap is other gaps. Total gaps minus max gap. So it will become 2 max gap into 2 minus total gaps. And you remembered max gap is mx minus mn of the array minus total gaps, which you have already computed. So this operation 1 will for sure be required will be this. Then you realize operation 2, okay, operation 2 is all the gaps which I have, which is the total gaps. I know that on this operation 1 number of gaps, I will have to apply operation 1. So remaining gaps are total minus operation 1 gaps. So this is remaining number of gaps. And in these remaining gaps, I know I will have to apply operation 2. And I know that for the remaining gaps, I can, if I apply operation 2, I can pair them up. So if I pair them up, it will become a operation number of, these are remaining gaps by 2, it is for operation 2, and it is a cost of 2. And this is for the cost of 1, which is operation 1. Okay, but Aryan, you assumed that all the other gaps you are pairing up with the maximum gap. This is what you assumed. But I'm saying, what if I'm not pairing up, as in like, okay, what if this is small and I have still more gaps? Okay, let's see that case also. What if I have still something else remaining? Which means, as you can see, I had a 7, 4, 2. If you remember, I had a 7, 4, 2. I made more gaps. Okay, 5 and 3. Now you can easily see that these gaps are actually more than my maximum gap. So am I saying that I will not be forming any gap? No, I'm not saying that. There's still a chance that one gap can still remain. But okay, did you see? I specifically mentioned, I'm not saying operation 1 number of gaps will remain. I'm saying there's still a chance that one gap might remain, because I know that if I can for sure club them up, make a pair, and make any number of pairs. I can form that. And I can also know that whatsoever gaps I have, anyway, I know that anyway whatsoever, all these can in worst case make a pair with the maximum gap. So for me, that edge case is no more there, which is this edge case, which I showed you. This edge case is no more there. So what's the case then? It's a case that, okay, maybe I place one here, then 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 one here. So after placing, okay, I can place all of them. There's still a chance. You are placing in pairs. Then still, if the number of gaps remaining are odd, you might end up missing one gap. So it is what I'm mentioning. If your gap is more than your other gaps, you can make all the pairs, but still one gap can remain, which is, you are saying that everyone, which is the total gaps whatsoever you have, if they are even, no operation 1 will be required. If the total gaps are odd, then one gap will still remain, and that will incur operation 1. Now I saw this condition, let's mix those conditions. So I am combining these two conditions, and I'm saying that operation 1 will be, as you can see, operation 1 was maximum minus minimum into 2 minus total gaps, which is maximum minus minimum into 2 minus total gaps. But this is only applicable when your max gap is more than your other gaps, else this will become as negative. So we realized we also can have your max gap can be less than your other gaps. So make sure to handle that condition also. So that's the reason I have put a 0. That if this is negative, okay, put the operation 1 as 0. I am by default assuming operation 1 will be 0. It is not the case. I still can have one operation 1. I can still have half. So this is not showing the correct value of operation 1. It is not correct. It is showing according to this criteria and handling this case also. But this case might still remain. How I will handle that? Let's see. For operation 2, for sure, as we saw also remaining, it is total gaps minus operation 1. Total gaps minus operation 1. Now, this is the operation 2 number of gaps. which I knew for sure I can form a pair. I can form a pair. But here I realized, what if it is still remaining? What if it is still remaining? I cannot form a pair. It is by this condition, which means I still have one gap left. So in this case, when your operation 2 have this operation 2, which means whatsoever remaining elements you have, if you have odd elements remaining, which means you will have to use one operation 1. And because of this condition, I am actually taking in consideration this case, which I was missing in operation 1. Right? So I take this condition. Again, operation 1 condition is already there. Cost 1 is already there. Operation 2 by 2 cost is already there, and into cost 2. This is the case. This is the case when I know that I will try to bring all the elements to your maximum element by utilizing the fact that I will try to make operation 2 as much as possible. And that is the case. This is the exact code. Operation 1, operation 2, and then the result. Right? Okay. But you saw one thing, that when I was mentioning the case, I was mentioning that you purposely made sure that you are bringing all the elements to the maximum value. But then I also mentioned, okay, this is what you have studied right now, case 2. But I also mentioned that you can still overshoot your maximum value to reach an optimal answer. But Aryan, how can you say that? How can you even say that? How it's even possible? It is. If you remembered, I asked you to just remember this diagram I showed, that for these gaps, I can represent these gaps as a form of an array. Now, let's utilize this array to understand how actually I can overshoot. I can actually overshoot my maximum limit to reach my optimal answer. Okay, let's see. Now, taking the example, let's say you have 2, 4, 5, 7. Again, I made the simple array. I made the gaps also. These are the gaps. I plotted these gaps in the array which I showed you. Okay, one gap, 1. Again, for a gap of 1, I have the 1. I have only 1. Again, this is saying for a gap of 1, I have one value only. For a gap of 2, I have one value. For a gap of 3, I have one value. For the gap of 5, I have one value. This shows the frequency of the gaps, and this shows the actual gaps itself. Now, we know that at every step, what I was doing? At every step, I was choosing 2 maximum gaps. If you remembered, at every step, I was choosing 2 maximum gaps, 2 maximum gap values, and then reducing both of them by 1. Same way, let's do it here also. Choose 2 maximum gap values and reduce both of them by 1. So if I reduce the 5 by 1, he will become a 4. If I reduce 3 by 1, he will become a 2. So these will go away. 5 has gone. It has now become a 4. 3 has gone. He has now become a 2. This is how I will populate, or how I'm showing you. Again, I'm just dry running you that how this is happening. So, okay, this happened. Awesome, awesome, awesome. Then again, as you can see, you achieved this. Now again, take 2 maximum gaps, reduce it. I take 2 maximum gaps, I will reduce it. So this will become 0. Here I can bring 1. This will become 1. This will become 2. Okay, 2, 1, 1. As you can see, 2, 1, 1. Now again, take 2 maximum gaps. This will become 0, and this will bring a 1 here. This will become 0. This will bring a 1 here. Okay, you got a 3 and a 1. Again, choose 2 maximum gaps. Okay, 3 and 2. Make sure, मकसद नहीं भूलना था. Your main aim was to ultimately reduce all these gaps to 0, which means bring all these gaps to this gap 0. Okay, let's come on back. So take 2, take 1. Okay, reduce this. This has become 0. It will bring a 1 here. This will become 2. It will bring a 1 here. But again, bringing a 1 here, which means gap 0 I have reached, truncated. I have reached my answer. Go on back. Oh, that's done. That's done. So ultimately, I reached a 2 and a 1. So here the value is 3. So you are saying that you have three gaps remaining of 1. Okay. In our case, I can say, okay, I have 3 gaps remaining, which are 1 gaps of height, 1 height of gaps. I can for sure make 2 of them as pairs. 1 can still remain. Okay, I can make 2 of them as pairs, and 1 can still remain. Okay, so this you can see, I bring it to 1. Now you are saying, Aryan, you are saying that 1 gap will still remain. I'm saying that, but I also said that I can still increase. This was happening because you imagined your gap values on the basis of this threshold, which was the threshold of 7 maximum height. These gaps were computed by taking in consideration the maximum height, which is the threshold which you have taken. Now I'm saying I can go beyond this threshold. I can go beyond this maximum height. I can go maybe 8. How? Let's try this. Let's try. So if I am going one step ahead, I know, okay, only one gap is remaining. But that cannot form a pair. He's just one. He's alone. He's a loner. But I'm saying everyone was able to reach to 7, which was maximum height. So the current condition, which you can see right here, can be represented as this, that all the heights have reached to 6 and all the other heights have reached to 7. This is the current condition. And you know you have just one gap remaining. Now I'm saying, what if I would have took the maximum threshold as, let's say, 8? If that would have been the case, this is now my new threshold, which is 8. If that is the case, what are the new gaps which you are introducing? I'm introducing gap of 1, gap of 1, gap of 1, gap of 1, and this is a gap of 2. So the current gap state looks like 2, 1, 1, 1, 1. Now, if I just plot this, I know, okay, for a gap of 2, I have just 1 frequency. For a gap of 1, I have 4 frequencies. Okay, 4 frequencies. Sorted. Again, let's try to reduce it. Same way. Let's take 1 from here. Let's take 1 from here. Again, as I take 1 from here, I will have a 1 here, right? And then when I take a 1 from here, I will put a 1 like here, but 0. I don't matter. Okay. Now the condition is 4 here. 4. I have 4 gaps of length 1, length 1, length 1, which means I have 4 gaps like this. For sure, I can make them pairs. So here I will bring a 0, and you can see easily that I was able to actually make, again, if you remembered, you were having 1 gap remaining, but then by adding 1 more threshold, okay, you went on to maximum of 8. You actually went on and took all the gaps as cost 2, as operation 2. But Aryan, why is this useful? Like, you are actually using a cost of 2. You are actually increasing the gaps. Okay, and you are using a cost of 2 internally for that. Yeah, true. But how that can be helpful? It can be helpful when you know that your cost of 1 is very high and cost of 2 is very low. As you can see here, you would have incurred a cost of 1 because you have only 1 gap remaining. So cost of 1, and cost of 1 we saw very high, as in 1 is 6. But then by simply taking, as you know, that my n was very small. My n was simply my n was 1, 2, 3, 4, 5. My n was a 5. So I simply saw that I can simply increase my gaps by 1. Okay, which means simply increasing them in pairs, right? Because you can put any limit. It is your task is to increase. You can increase to any limit whatsoever, and I saw I can increase in pairs. So I realized I can utilize all the cost to operations, and max to max how much cost to operation can go, maybe 50, 40. Again, I'm saying worst case. Again, n is here like 5 only, so it will go at max 5, 6, or maybe 10 mass. But I'm saying how in comparison it is with cost of 1, it can be very high. So we realized, okay, it is still possible to go beyond the threshold of the maximum element. Okay, great, done. So if I ask you that you were taking the gaps in consideration. If you took the gaps in consideration, you have this gaps array. You took this in consideration, and then you reached to an answer. This is a final state you reached when you took the gaps in the beginning state of gaps in consideration. But then you realize, what if I do a 1 step increase? Then I reached this specific array. So if you look closely, from this array, you took 1 more step where you increased all the n elements by 1. You reached to this array in which I had a 1 already. I added a n minus 2. As you can see, n was a 5 for me. So I added a 3. And I got a 4. But Aryan, is this a formula, or like are you driving it? I'm driving it because if you remembered, if I will add a 1, what will happen? If I add a 1, so existing gap was a 1, he will become a 2. So he will shift one side. Wherever he is, he will shift one side, and he will be at that location. Okay, he will shift one side. Then for the other gaps, I know, okay, 1 gap I have shifted, remaining gaps are n minus 1. So I have n minus 1 gaps remaining here. So I have n minus 1 here and 1 here. As you can also see, I had n minus 1. Sorry, I had n minus 1 here and 1 here. This was the state, and ultimately you saw that again both of them will be adjacent to each other because you are shifting by 1 gap only. right? Both of them will be adjacent to each other. It can be anywhere. It can be here also, n minus 1, 1. So make sure both of them will be still adjacent. Now, again, sorry, here it will not be there because you are adding a gap of 1, so it will be here itself. Now, when you have here at this stage n minus 1 and 1, you know that this can still come down. So as he will come down and become a 0, he will add a plus 1 here. He has to go on his left, so he'll do a minus 1 and then he will go his left. So you will see that, okay, I will actually do nothing. This is n minus 1 here itself. Ultimately, if you remember, in the very beginning I had a 1 here, and I am saying the new state will be n minus 1. So how much I added? I added a n minus 2 here. So I realized that from this state to adding one more threshold, I will just need to add a n minus 2, and I will reach there. Aryan, how this is helpful? This will be helpful a lot. How? Let's see. So we realized that maybe as soon as I reach, I can maybe add this n minus 2, and then I can again add this index 1. At this index 1, I can just add it and I can reach my next threshold. Now, if I try it and I want to find out, okay, Aryan, but you just increased one step, but how many times will you increase it? You just increase one time. Okay, it was max equal to 7, you just increase it to 8. But maybe I have to increase more times, 8, 9, 10, 11. But how will you even monitor that? No worries. I know I have to increase some number of times, right? I know that this is the current maximum value. And at every increase, I will increase by 1. Now, if let's say I'm saying I'm increasing my maximum value, which was 7, I'm increasing, let's say, 5 times. So all the n values, they will have to increase, the gap will increase. The gap will increase for the n values. For all the n values, the gap will increase 5 times. So how much the total gap will increase? It will increase by the number of times I have done this increasing stuff into the n. These number of gaps will actually increase from your base gap, how many gaps you had, which is this existing total gaps, and then you thought of to increase times number of times you thought of increasing this maximum threshold. So this is the extra number of gaps which you might be encountering. Now, how will you find that how many times you should increase your gap? How will you find that? Simply, you know that you will have one loner gap remaining. He is saying I have one loner gap having a gap size of 5, having a gap length of 5. He's a one loner gap, and I know that I have to just somehow remove this loner gap. So if I have to remove this, I need to make him pair with someone else. If I make him pair with someone else, I know the gap will keep on reducing, right? So this is my ultimate aim. I just need to bring this loner gap, and I know this length is very high. I need to bring this loner gap, and this is saying operation 1. If I don't apply any dimag of mine, I will actually be using operation 1. Again, operation 1 says this have 5 gaps, and again in one index only, one gap of 5 length, you have to apply 5 times the cost of 1, which is operation 1. I don't want to apply it. I will try to reduce it as much as possible. Again, what's the worst case? Worst case is still I will have one gap remaining of a length of 1. That's the worst case possible. Okay, let's try to bring this gap. How will I bring it? I know at every threshold increase, I will increase by n minus 2. And I know that this is operation 1. I need to bring it to my gap 1 length. So simply n minus 2 is your this. At one time you will increase this threshold, and because of this combination, I can keep on shifting this element of gap length 5. How? As you can see, I did a n minus 2, which is 4. So I have a 4 here, I have a 1 here. Remove this, get a 1 here. Remove this, you have a 3 here. 3 here, 1 here. Again, he will shift left, he will become a 2. He will shift left, he will become a 1, and ultimately he will be 1 here. So you realized I use this one threshold increase to shift my operation 1 to its left, and ultimately brought him here. Again, I'm saying still in worst case, it can be possible that you still might have one gap remaining of length of 1. But still, I have reduced all this. Now I have no gap of 2, like no gap length of 4, and so on and so forth. So I'm safe. Even if worst case, I can only apply operation 1 just once. That's it. That's a worst case possible I'm taking in consideration. What you did actually, you have to find out times. How many times will you shift this? Will you shift this operation 1? What if 8, 9, 10, 11, 12, 13? What if this operation 1 was here? You have a gap length of 13. Operation 1 was here. Then how many times will you actually do this n-2? Because here you applied n-2 just once. So you have a 4. By this 4, how much you can increase? How much you can shift? You can shift maybe up till here. But still you should have more n-2. Okay, I add more n-2. I shift maybe up till here. I add more n-2. I shift up till here. So this number of times I add n-2 will actually help me find out how much I should shift my operation 1. So I'll say operation 1 upon n-2. It is the number of times I should actually do this threshold increase. And I remembered this is the times multiplied by n will give me the total gaps increased. And again, I know the operation 1 can still remain. That can be operation 1 mod n-2. Again, you see that again, there's still some things remaining. I will show you with this still. You might say, Aryan, but you mentioned that in worst possible case, you were saying, Aryan, that only one threshold only one gap length 1 will remain. But here I can see that still the gap length can be n-3, n-4, and so on and so forth. Are you serious? I am. Let's see how. But still, okay. This is the remaining number of operations 1, which can still be there by this technique which we have seen. But my fact, I will go on to that fact later on. So if I have these many operation 1 remaining, what are the operation 2s? Operation 2 remaining will be total gap minus operation 1s. Same way as we did exactly as we did in case 2. Exact same formula. So if I utilize this fact that again, this case 3 says that operation of my maximum threshold can increase. So this will be my strategy, that in case 3 I am saying my maximum threshold can increase, and it has increased. This is this total gap. This is operation 1, this is operation 2, and this is my result. Again, I am just trying to minimize my result at every step. But now coming on to fact, Aryan, what if your operation 1 is still remaining? As in what if it is still in the bounds? What will you do for that? Okay, no worries. If that is the case, I will try. What I will try? Let's see. So if I go on, where is this gone? Okay, so I will still try. Now, what if, okay, let's erase this. Everything, it is untidy. So we realize that, okay, we can still, and again, with these 2 facts, we can simply realize that we can still have some operation 1 remaining, which is inside my n-2 length. So n-2 was 7. Operation 1 was at 5. I know that with the above formula which we saw, case 3, we will not be able to actually help it out. How will I do it now? I realize, okay, if that is the case, I should for sure try. Okay, I will try applying n-2 here. I applied a 7 here. Okay, it was missing by the case 3. I should apply it. I should actually use it. Okay, I will use it. This is operation 1. I put the n-2 here at next one, and then I said, okay, let's try to shrink it. Okay, so again, with this help, I will actually be able to bring my 1 here, right? Okay, as my 1 is bringing here, what will happen? Okay, this is the case as you have applied here. So you might end up bringing your 1, but still, as you can see here itself, that you still, okay, you have got all the block lengths of 1, but okay, you have 3 blocks. Okay, in worst case, you can make one pair, and still you will have 1 block left. Are you saying that still you will have to apply operation, still you have to apply operation 1? Are you saying that? I'm saying no. Let's try one more time applying operation 2. Let's try one more time applying operation 2, which means let's add this n-2 one more time. What I will do? Okay, I will add my 7 again. This is the 1 left. I will add my n-2, which is 7, one more time. I will get an 8 here. 8. I have 8 blocks of length 1. I can make 4 pairs. All these are gone. I can just use operation 2 here. So I'm using operation 2. So you realized after applying the case 3, I can apply my n-2 operation, which means adding n-2 here, as in is trying for that possibility. I can try it twice, one here and one here. So what I did, I increased my threshold twice. So the total gaps I am trying to increase twice. As you can see, this loop will go twice. Once it will increase the threshold by 1 and will try to find the answer. Again, it will increase the threshold by 1 because of this possible case can be there. And again, he will try to get the answer and minimize the answer. Again, he's minimizing the answer at every step. As you can see here also, I was minimizing the answer because it can happen that maybe answer is increasing here because of maybe some case is not even having a 1. He already had a 0 here, for example. So you might end up increasing your answer. So it's the reason I'm minimizing the answer at every step. Whosoever gave me minimum answer, that's my actual final answer. And ultimately, this was the code with these 4 cases which I showed you. Firstly, I showed you these. Then first case was that you only take operation 1 in consideration, and these 2 were the cases we explicitly saw. Then case 2 was that you will take operation 2 as best as possible, as many times as possible. Okay, in worst, again, your threshold limit will be maximum element of the nums. And then in worst case, you can take your operation 1. This case says that, okay, bro, I will try to go beyond my threshold. I will try to go beyond my threshold. But then, because of the formula which I have taken, there's still a chance that I might still end up having more operations once, which means the numbers which are less than n-2, the operation 1, which are less than n-2, can still be there. So as to counter, or so as to handle this specific case remaining, I took and applied my operation 2, as in like increase the threshold twice, and that's the answer. And ultimately, don't ask me the time will simply, as you can simply see, it is, as you can simply see, O of n, because of to find the maximum element. So it's simply O of n. Again, every step else is a O of 1 operation, and thus the time ultimately is O of n space. As you can see, you are doing nothing with the space, no space used, so space will be O of 1. And this is the most optimal solution of this specific problem. Again, the entire code has been written by Lee, so a big shout out to this guy, but the explanation was 0, like legit a 0. If you want to save your time, go watch this post, try to explain it, try to understand it as much as you can. Hands off to you. If you can get it, well done. Now coming on last, this video took a lot of time. Again, this is not the daily problem which you should be doing. Many people were asking for it. That's the reason I have to make it. Again, you can see it is Monday 11:22, right? Okay, I'll not show other things, but it's Monday 11:22, right? It takes a lot of time to make these videos. If this video, again, you can like and subscribe, that will be very helpful. If this video doesn't get 150 likes or sufficient number of subs for these kind of long videos, post contest, I will try to avoid. You might say, Aryan, we can watch others. I will highly recommend go and try to find any other solution which will be this optimal with this explanation. I tried to see, okay, shall I make this video or not? So for that, I looked on and went on back to the other videos, and I saw there were 3-4 videos for this problem, and everyone said one thing. Okay, we will tell you this is happening, and then okay, we as you're doing programming, so we think that you should be knowing this concept. How will a person know all these edge cases? Is it possible? Is it even possible to think of these cases? No, it is not. That's the reason it was rated 8. It was solved by just 109 people out of, I guess, 8k people who were able to solve question number 3, I'm saying. So yeah, that's it. Too much ranting. If you liked it, again, please a sub will be very helpful, or you can just share with your friends. That's all. That's also again will reflect, and I will be highly grateful to you guys. Peace. Bye bye.